Hello, in this video we will work over an example of partial fraction expansion. So let's say we had this rational x squared minus 2x minus 37 over x squared minus 3x minus 40. So as you might recall, our requirement is that the degree of the numerator is less than the degree of the denominator. 2 is not less than 2. So this doesn't work. First we must divide the two polynomials. So we put our numerator inside the little house, and we divide it by the denominator. So how many times do you multiply x squared to get x squared? So you need to look at here the terms with the leading coefficients, and so we just need to multiply this by 1 in order to get x squared. So we have x squared minus 3x minus 40, and we subtract that from whatever we had before. Let me use another color so it's easier to see. And so we get 0. Negative 2x minus negative 3x is positive x. Negative 37 minus negative 40 is positive 3. So as you can see, we do not need to continue since x has degree of 1 and x squared has degree of 2. Just a little tip, hint maybe that you probably already know, is that if the degree of the numerator and denominator are equal, you just need to divide these once, and that will always decrease the degree of your numerator by 1, so that would be more than enough. I'm sorry. And so we have 1 plus x plus 3 over x squared minus 3x minus 40. Very well, so now we're still not done. We see that there is a polynomial on the numerator, and we want to get rid of that. So let's factor out the denominator like we mentioned in the previous video. So as you might recall, if we have this polynomial right here, we want to find an a and b that when you add them, you get negative 3, and then when you multiply them, you get negative 40. So remember that this is our constant term, and this is our coefficient of the linear component of just x. And so let's list the factors of negative 40. Since negative 3 is negative, we want the greatest factor to be a negative. So for example, we can start with maybe negative 20 and 2. We can decrease this to maybe negative 10 and 4, or maybe, well, 5 and negative 8. See how I keep the negative sign with the greatest, with the greater number, since here we have a negative number. And so voila, we see here that negative 8 plus 5 is equal to negative 3. And that, of course, negative 8 times 5 is equal to 40. So we found a is equal to negative 8, b is equal to 5. And now we just factor out like we learned before. So let's just do x plus 5, and then minus 8 plus 5x, I'm sorry, minus 8x minus 40. And now we just group them. Here must be a plus, and so we have x plus 5 And here we can factor out a negative 8, since that's a factor of both. And so we factor out a negative 8, and we're left with x plus 5. Oh, so sorry. Remember that here is a square right there. And so here actually we need to factor out an x from here. So we can factor out an x, and we get that. And so we just kind of do the distributive property in reverse. We take out the x plus 5, and we're left with x minus 8 times x plus 5. And those are our two factors of x squared minus 3x minus 40. Our two factors are x minus 8 and x plus 5. So now, having that, as you may recall, we said that there is some number a over x minus 8 plus some number b over x plus 5 that is equal to x plus 3 over x squared minus 3x minus 40. However, how to find a and b? Okay, so here we will put into practice what we learned before on how to add rationals. So we have a over x minus 8 plus b over x plus 5. And if we were to add them, remember that we must find the common denominator. Here it's very easy. We know that both of them are factors of this polynomial, so it's very straightforward that their common denominator is just x squared minus 3x minus 40. But as you might recall, we must multiply a by whatever we had to multiply its denominator by. So to turn x minus 8 into x squared minus 3x minus 40, we had to multiply by x plus 5. So we must multiply a by the same thing, so a times x plus 5. And then same thing with b. We had to multiply x plus 5 times x minus 8. And so we must multiply b by the same polynomial. So plus b times x minus 8. And we know so we know that a times x plus 5 plus b times x minus 8 is equal to x plus 3. And now we need to find what a and b are. So what we can do is plug in different x values to get rid of that variable and then solve for a or b. However, we only have here one equation, and if we get rid of x, we still have two variables. We have a and b. So we need to find a way to get rid of x and at the same time get rid of either a or b. And a very easy way of doing this, which is the way we will always do it, is by making one of the terms equal to 0. If we make one of the terms equal to 0, we're left with only one variable. So to make x minus 8 equal to 0, we need to make x is equal to 8. So let's find what this equation is equal to when we substitute x with 8. So we have 8 plus 5 is equal to 13, so 8 times 13. 8 minus 8 is equal to 0, so 0 times b is just equal to 0, so I will leave that out. And then here plug in the 8 as well, and we get 11. So to solve for a is just now divide everything by 13, and we get that a is equal to 11 over 13. So we have found our a right here. So this is 11 over 13. Now we do exactly the same thing to find b. So what would make x plus 5 equal to 0. So x plus 5 is equal to 0. Subtract 5 from both sides and you are left with x is equal to negative 5. So we must plug in negative 5 for x, and that way negative 5 plus 5 is equal to 0 times a is equal to 0, so I'll leave that out. I won't even write it in. And b, if we plug in negative 5 right here, we get negative 5 minus 8 is negative 13 is equal to negative 5 plus 3 is negative 2. So we divide both sides by negative 13. Here the negatives cancel out and we're left with b is equal to 2 over 13. Now we just need to go back to our original equation and say that this is equal to this, which is equal in turn to 1 plus 11 over 13 over x minus 8 plus 2 over 13 over x plus 5, which is what we got before. So this is the partial fraction expansion of our original equation.